In the last couple of episodes, we have explored some standard implementations of Game of Life, so it's time to spice things up. In this episode, I will turn everything into functions, even the data structure. Stick around till the end because the result is pretty unique. If you haven't seen the previous episodes, you can catch up on those later. But if you don't know what Game of Life is, you might want to watch the first few minutes of the last episode where I explain it. Link is in the description. Okay, so let's get started with this. So this time I would like to evolve the function that takes a function which will represent our world and then returns a function that represents the next state of the world. So our empty world will be represented by a simple function that takes two parameters, the x and y coordinates of a cell, and returns if that cell is alive or not. I will introduce a constant for that so that we can easily change it later if we want to. And then the evolve function will take this and then return another function. Of course, this is failing now because evolved is not a function yet, so let's just create a function here. And after that, we can just call that function that was returned by the evolve with 0, 0. That's not a function yet. So we need to make sure that we are returning a function. This could be basically any function. And now we also want to make sure that we have some expectation, right? So we want to make sure that the cell in 0, 0 is dead. Now, of course, that is failing. But to satisfy the test, it's really simple because I just make sure that I return the same function that I got. So this basically says that our world is not changing, which is actually true for an empty world. It always stays empty. Okay, so now with that easy setup, let's go on to the first interesting case, which is that the 0, 0 cell, if it's alive but alone, then it dies. So the easiest way to create a function that has a single living cell is to explicitly say that x equals 0 and y equals 0, then it's alive, otherwise it's dead. And of course, for that to work, I need to make sure that I have the alive constant defined as well. Now to satisfy this test, we just need to make sure that we are returning a function here that is always returning dead, because right now we are only checking for dead cells. And we actually have a function like that here, so let's just copy and paste it over here. Next, we need the test where the cell is in a living state after evolving. So one such case is when we have two neighbors. Now, one way to create a world in which the 0, 0 has two neighbors is to just make sure that it's a line, a vertical line, for example. So if I delete this second part and just say that x equals 0, that's going to create a vertical line for me that I can use. And of course, the expectation is that it's alive. Well, one way to satisfy this test is just to check one specific cell, and that satisfies it. That's of course cheating, because this is not looking at any counts of neighbors, but we will get there. So next case is when we have a single neighbor, because right now, if this 0, 1 cell is alive, then we will make the whole thing alive. Instead, let's look at one specific case where that cell is alive, 0, 0 is alive, but then it should be dead in the next iteration. Now the trick is that we need two different cells with two different y coordinates, but we can still use this pattern that we've been using so far and just say that if the -1, 0 array contains our y coordinate, then it's going to be a true and the cell is going to be alive. Oh yeah, and we actually need to call this function. So then this test can be satisfied by just checking the other cell as well, the 0, 1 cell here. I think my tests are not very clean at this point, so let's do a bit of refactoring there. I would like to create a domain-specific language for generating these functions because it's not very intuitive to understand what these things mean. So what I will start with is just creating a simple function, and then I will also create a spawn function. And that spawn function would actually receive the world as this value. So this spawn function will return a function that does exactly the same thing as the function was invoked on, but also returns alive for the xy coordinates that we passed it. But to make sure that we can invoke this spawn function on the world, we actually need to put it on the world. And because we want to chain this, so that I want to be able to spawn multiple cells, I will have to extract this into a variable and then monkey-patch the spawn function onto that as well. So now we can start refactoring these things here. So this is just simply world here. Let's move this one as well. Oh, one thing. I forgot to add this here. So instead of this single cell, I can just say world spawn 0, 0, and basically does the same thing. Okay, then this special case here, we have a very simple function. I'm not going to replace that for now, but this one with spawning 2 different cells, I'm going to replace it. The other thing is that like this doesn't read really nice. Expect evolved word spawn 0, 0, 0, 0 to be that, like it's not clear which 0, 0 is which one. And for that I will create another simple function called expect cell. And actually I'm going to return an object here that will have one single key called n, which is a function, and it takes a world. Now I can just write expect world xy and just return this. So now let's replace this one first, for example. So now that we did the first one, let's try to write a replace for the other 3. I'm going to capture the world that is being tested. Okay, now this reads much nicer and we can move on to writing our next test for our little function. But before I do that, I actually want to do one more factor here, because this is actually like when we say here these 2 cells should be alive, what we really mean is that there are 2 neighbors that are alive, and these 2 specific neighbors. So I could make this more expressive by saying that I have the -1 and 1 coordinates for y, and then I will just map that to world 0 y, and then I'm going to do a reduce and just sum up the values like so, and this should equal to 2, and this whole thing is equivalent to our original code here. Okay, I really hate to write this reduce, because like summing up values in an array, that's such a frequent thing to do. That should be an array function, so let's make it an array function. Now we are going to move on to our next test, and I'm going to again have 2 neighbors, but different 2 neighbors, so that I can force the implementation to check other neighbors as well, not just the 2 that we have checked so far. And one way to satisfy this function, we could just copy this and add it together, and that should actually satisfy our test. But of course, again, I feel like refactoring, I could again create another map that looks at these 2 values, but of course this becomes a 2-dimensional array, and that's not good for our sum function. This would now add those arrays together, so I have to change this map into a flat map, and then it will just list all of the neighbors that are currently being checked. So right now it's looking at 4 specific neighbors, but it's not looking at the middle neighbor of the 1 row. So let's also look at that. And one way to do that is just to introduce here 1, 0 in the center. That of course breaks a couple of other tests, because now we suddenly check the middle cell as well, but we can fix that by just subtracting here. And now we actually have to just add one more item to these arrays, but for that we need another test, of course. Okay, so this is actually a pretty decent neighbor counting mechanism here, but what I don't like about it is that we have this map, flat map. This should be much simpler, so I will actually create a constant that has all of the deltas, and we will use that here instead. Now I can just say deltas map, and then the x and y coordinates are coming through an object as dx, dy coordinates, because it's actually deltas, and done. Okay, so from here you already see where this is going. We just need to write a couple of more tests to force this part of the code here. So next test is actually checking if cells with 3 neighbors survive, then check if cells with 2 neighbors that are dead are not spawning, but cells with 3 neighbors do spawn. And then finally we need to check if a cell that is not the 0, 0 also works. And for that we need to do a couple of things. So for example, we have to add the x and y here, but it actually satisfies this specific test, so we need to write another test. So the previous test only forced the x and y coordinates into here, but we also need to force it in here and here. So to force it here, we actually need to look at the case where there are 3 neighbors and the cell itself is alive and it's not the 0, 0, because then we will have 4 from here unless we subtract the correct value. Okay, so that test actually forces this here. So now we only have to force this last one, and for that we need a test where there is a cell that is dead and has 2 neighbors, and there is a 0, 0 cell that is alive. Then we'll have to actually check the correct value. And actually that's a complete solution, and I really like this solution because it's the smallest, simplest, shortest solution I have ever seen. If you think of it, it's like the actual eval function is 4 lines plus the generation of the deltas, and well, this function sum that should actually be part of JavaScript, but it isn't for some reason. So I really like it. It's like amazingly simple, and if you really just want to write a really simple implementation of Game of Life, this works every time. So basically what we do is just do a neighbor count. We look at all of the cells, including the center cell, but we can subtract that and then just check the rule, and that's it. No for statements or anything. It's right, absolutely the simplest solution I have ever seen. What do you think of this solution? Did you find similar tricks useful in your day job? What other crazy constraints should I try in the next episode? I have a couple more ideas, but leave yours in the comments and press subscribe to find out how that turns out. Until then, keep coding and carry on.